Hello.
Hi, Emil.
Hi, Robert. Hi. So the video is good. Perfect.
It looks good for you. Yeah.
Say it again.
Yes, your video looks fine. You had it on.
So I just pushed the version 2 of the use cases. So it's online.
Excellent.
2 minutes ago.
I've still got a couple of documents I need to push and update for the deadline later
Just to say
today.
that with Key, Mysol, we have been fine-tuning all the detail, and then I clean up, you see the reference, and now so we have something, I would say, acceptable.
Excellent.
And with the contribution of all the authors.
Right. I think we should probably start. So we're just past the hour, so we can at least go through these earlier slides. So I assume, Diego, you're there somewhere. I haven't heard from you. Just to check you're online. If not, he'll catch up, I'm sure. 1 moment, just pin.
I'm here, Rob. Just that I was trying to unmute myself. It's not so easy because this afternoon I have sort of 100 windows open on the.
The next question Mohammed just asked: is this meeting going to be recorded? Do the interim meetings get recorded by default? I don't know. Yes, I think so.
I see it recorded, and the other day checking the minutes, etc. I saw that there were recordings from the others.
Okay. Yeah. So the answer to your question, Mohammed, is yes. The session is recorded. So we'll go through the agenda fairly quickly. I appreciate that this was sort of fairly last minute in terms of setting this up, and I'll explain the details of the reason for that. We will have a fairly informal session today is the plan, and that's sort of what we're hoping to go forward with, so we'll discuss that. We'll have a little bit of time just to discuss the upcoming IETF 123 meeting at the end, but most of the time I'd like to spend sort of discussing the open issues and things. In terms of people who said they can make it, there was 1 or 2 participants who said they can only make the second hour. I'll see how we go for time and for sort of making progress with the issues. So just the note well for anyone who's new to the IETF to be aware of. I'll leave this up for a couple of minutes for you to read while we go through this. You need to be aware of that everything you do and participating in this meeting, everything you say counts as contribution to the IETF, and there's various implications of doing that, and in particular related to IPR that you want to be aware of. So if you're not familiar with the IETF processes and procedures and what the implications are, then I would strongly encourage you to both read this now, but also read this offline as well, particularly a bit related to patents. So I'll just leave that up for a minute or two. 1 minute maybe. I think most people will be very familiar with it. Okay, and moving on from the formal note well, we also have the informal note well, the note really well, which is effectively saying this is a professional meeting and we're all polite and kind to each other, and it's absolutely fine to express your views and things, but try and do so in a way that's respectful to the other participants in the meetings. So I'll leave that up for a moment while you do that. And if you do have any issues or concerns, then number one, you want to flag them to Diego and me, but there's other avenues you can also flag the issues to. There'll be a moderation team at some point being created soonish, I hope, but also the onboards team as well is available, and Mahesh is AD. So moving on to the actual agenda for today. So very simple, the green data model planning. So we'll have 10 minutes to do that. So I sent an email out about this on Friday. Sorry, this is short notice. Obviously, Diego and I have also been busy, and we needed to sync up with Mahesh to check he was okay with the plan. So I'll just go over that today to check that everyone is happy with what we're proposing or has any comments on that. And then the plan is that if we get sort of agreement here and nobody objects to it, then we will try and move forward with that. I think start a little bit the IETF 123 meeting, but predominantly trying to arrange regular semi-informal interims after that. So have a 10-minute session on that. Then the idea is to spend the bulk of today sort of going through the issues that I pushed up, presented last time, like 3 weeks ago, with the aim of trying to sort of resolve some of those and make progress as a tool or a mechanism towards getting agreement on the data model design. And we'll carry on with those. And I've got 10 minutes for sort of future planning, next steps, wrap up, etc. And I guess probably pre-IETF 123 planning in there, which will be a reminder to put sort of submissions in if you want to present. And that's it. So any agenda bashing, does anyone have anything else they want to change on this agenda or any comments on this? I've put the meeting notes link in the chat. It'd be appreciated if everyone can sort of help make notes. I don't think we necessarily need to summarize all of the discussion. It would be good, though, if we do get some sort of level of resolution on any of the points to try and capture what the resolution of those. That's the key thing that I think is most helpful.
Cool. I'm trying to follow the discussion. Thanks for notes. I have the note taker open.
And I do too as well. So I'll try and do it at the same time. Okay, so there's no comments on this one. So I'll move on to the green data model planning, or plan, I think you should maybe say. Data modeling next steps. Okay. So this is just a copy of the email I sent out. So I'll put it up there for you to read effectively. And this is based on the discussion we had at the last meetings. Previously, Diego and I proposed setting up a design team for doing this. And there were sort of 2 bits of feedback, I think, that came back on there, or maybe 3. One was the working group's quite small. Why don't we just do this within the working group? A design team's not necessary. I think that might have been from Tony. So yes, I can get some level of agreement with that. So we're going to try and do this in a sort of more informal way. The second comment was effectively about from Benoit saying that he thinks that having some level of chairing the initial discussions to help drive consensus is probably helpful. And hence, that means that rather than having a design team where you've just got 2 groups of people who've got different opinions on the solutions, they wouldn't necessarily get closer together. So the proposal was that we'll help chair. So Diego and I will certainly help try and chair the initial weekly meetings going forward. That won't necessarily mean that we'll both be there, but hopefully one of us will be there each week that we have these to try and arbitrate the discussions. So that was why we went in this direction. So hopefully this is more in agreement with what people would like. So the plan was have a weekly meeting, weekly meeting. I don't know, an hour or 2 hours, maybe an hour is probably the right amount of time on a weekly basis to go over the models. And the aim here is really to try and resolve those sorts of open issues and get traction and get the starting point of some data models and some agreement on what those look like. We also proposed, in terms of what I discussed, that we'd have like once a month, we'd try and reach a more formal agreement on various issues and things and make sure that the working group is updated on the mailing list as to what conclusions we've reached if they're not tracking these weekly meetings. We will have a GitHub repository to hold a working copy of a draft and data models, which people can put PRs against and track, classify the issues. That's not been created yet. And the idea is to sort of store roughly agreed text and agreed resolution of open issues, and the sort of the outline structure of the Yang models. So we all sort of converge on trying to solve the bigger issues first and then go down into the details is what I was thinking. I've asked Jan, and he's agreed to, at least in the shorter term, to act as the editor for this draft of the data models. That was a decision for various reasons. One, Jan has a lot of Yang data modeling experience and from his work for NSO. He's not working for Cisco anymore, so he's sort of mostly neutral party in this, in terms of different players and things like that. But he has strong personal interest in trying to find a solution. I think he wants to drive one relatively quickly. So I think that that's a good position. So thank you, Jan, for agreeing to do that. And again, it's not his job, or we're not setting him up to have to chair the meetings or moderate the meetings, but to act as an editor of the draft, so to pull the content together, and potentially if there are different sort of solutions being discussed and things like that, then we might ask Jan to sort of try and model those, so from one week to the next, so we can actually see what they look like, to help try and drive a solution more quickly. As I said before, Diego and I will help chair these meetings and I'll take the discussions. Again, I don't think either of us have necessarily a vested interest in the exact solution here. We're just here to try and help move the discussions along. We'll use the main green working list and also GitHub issue trackers. We had some discussion with Mahesh about whether we want to have the main green working group subscribe to the GitHub issue trackers for notifications of comments. And concern is that it might be too much noise. So it may be that the people working on this, we expect them to individually track against the GitHub issues at the same time, to track those and the main working list, working group mailing list. We may try and see if there's a script or an easy way to do sort of summaries on a weekly basis, but initially the expectation will be to track both, so we don't flood the working group. But discussion in both places is welcome. And then lastly, like all design team processes, initially what comes out of this will be close to like a design team document as a starting point, and people will have a right to sort of have a formal adoption process of that and check that wider people who aren't participating are happy with the way it's going. The hope is, though, that we're making good progress and getting people to converge and alignment, that we'd relatively quickly get this into a working document that can then be adopted, and we can progress under the working group umbrella. Any comments on this slide at all? Do just chip in or put your hand up, don't mind that, way. I assume that silence is people are generally happy with what's being proposed here, this approach. Hope so. And then the scope of this is sort of effectively the same as what we propose the design team. So the aim is to define a simple Yang data model offering a base energy data model covering component, device, and network level. So I know currently some of those drafts have been split out into separate drafts. This isn't really about where we end up, it's about where we start from. So we want to cover all of those. I'd suggest we start with one document at as a starting point. To identify and define any common groupings used by the models above, or any metrics and terms used by the model. So the scope of this group is not to sort of come up with new metrics and terms, except where they're sort of used by the model. So we'll have separate documents for those. We'll plan for those to progress in parallel, and also in terms of the use cases. So, but where they're needed, we can help sort of define those there. It is worth saying that Diego sent out a couple of liaisons, was it one or two liaisons, to Etsy and was it ITUT, Diego? And we've had responses back from both of them. So they've pointed us each to like half a dozen or so documents for us to look at, including some definitions and things like that. So there is some work to be done, either by the chairs or members of the working group, to look at those documents to see if there is content there that we should be considering. So that's something, if you are interested to look at that and do some of that work, that would be good to let Diego or I know. That would be helpful. There's a framework document that Benoit and others are sort of driving on the data models. So I think the framework is good. I think it helps put everything in its place. But in terms of where we are, that's not an adopted document. So there's not a requirement that the model must conform to a specific framework if there's good reasons for it not to do so. Equally, if it does align with the framework, that's also fine. So it's just to say that it's not that we're going to treat the framework as an adopted document. I think that's probably a sensible direction, but at this stage, that's not a requirement. And finally, the models don't need to be fully complete. They are the aim here is to sort of get the rough structure agreed, higher levels agreed, a common base structure, and then we can either refine those data models or augment them with extra data as it goes forward. So it's not like we have to solve everything. It may be, though, once we get progress and go forward, that is the right way. But at the moment, the key is to try and get common agreement on the structure. Any comments or questions on this approach? If I hear nothing, I assume everyone is happy with the way we're going here. So it is worth noting that this process of doing informal interims is sort of slightly outside the IETF process in terms of, I'm not sure they document it all, because it's not a formal design team, it won't be formal interims. But we have checked these with Mahesh, and he's happy that this approach is within the spirit of what IETF is meant to be doing in terms of trying to make good progress towards our goals.
And just let me add that it's a practical approach to the situation that we have had. There were several proposals on base models, or close to become base models that were not without a clear candidate with with a strong consensus supporting it. And on the other hand, it's true, and there was a comment that we got during the last interim that well, the group was not so big as to require a formal design team. So this is a way of trying to progress, trying to accelerate the consensus formation and practical, what I would call practical, and as Rob said, is something that we have shared with Mahesh, just to be sure that we were in good alignment with his views, and that we were not breaking anything. Just a reflection in loud voice, and really present a question for the two of us. Rob, probably we have to repeat this somehow in Madrid, assuming there will be a wider audience.
Yes, yeah, that sounds reasonable. Okay, so given there's no more questions on this, I'm hoping there's going to be more participation in the rest of this, because otherwise we're going to somewhat struggle. So the bulk of today is the modelling questions now. I shared these before. I've got the individual questions. The plan is to go over these. We started going over them last time. I think we should try and go over them in more detail. There is no particular order, so what I suggest is hopefully someone can suggest which issues they would like to discuss first. I've got slides with a few more questions related to this, but mostly they're similar to what I presented last time. Does anyone want to suggest one to get going with? Tony, yes.
So, I'm one for diving in on the deep end. I'd like to suggest that we start with question 3, granularity.
Okay.
And I think my opinion is well known, so I won't reiterate.
So I will note we haven't got, like Benoit, I know he has quite strong views on this as well. He's not here today. So I think actually, Tony, if you restate your views, that would be helpful, because I think that will help encourage discussion.
Okay. So the granularity should be very, very high level, because we've got some very smart, intelligent devices out there, and we don't really need a whole lot of granular control or monitoring. We can do some very simple things and enable a whole lot of functionality. The alternative seems to be to boil the ocean, to try to describe every possible power savings mechanism known to man. And that seems to be very, very complicated, and seems unlikely that we will get common functionality out of that.
Just to say, thank you. Just to say to others in these, feel free just to talk and jump in. We can moderate this as a queue if necessary, but I'm happy for people, if the discussion's sort of just flowing, to let people speak, and we'll moderate as a queue if necessary. So I've got some thoughts on this as well. I mean, I wrote some of these questions, so I quite like aiming at simplicity, and as I get older, I'm always keen to try and find a simplest solution that sort of meets the requirements. I feel a simple Boolean on and off might be too little. I think that maybe the state that you might configure to tell what state the device needs to behave in versus what state it's reporting is actually in probably differ. So I can imagine the case where a device like I don't know, optics might be in a high power mode, low power mode, off, etc. So there's more than just two states that it's reporting there. So I think that there would be difference in terms of what operational state is reported. I do wonder whether some of these states need to be tied to what the operation of the device is, i.e. the states that an optics might have could be very different from the ones you might configure for an MPU versus a line card versus a router. So I think some of those might be that we want to have data models with different levels for the different objects possibly. So that's another thought here. I do have a feeling that maybe Yang identities might work quite well. So I don't know, Tony, if you know identities that well, if you've looked at them, but effectively identities allow you to define some states, and then you can derive other identities off that. So on a very simple level, it wouldn't quite work. We could have an on identity and an off identity, and then you could actually refine off each of those to have the on one to have like high power, low power, and off the identity might be, I don't know, sleeping, hybrid sleep, I don't know, or cold sleep and off effectively. So, and again, those identities you potentially could refine what's there based on what the hardware supports, or whether you're acting on an optics or line card or MPU ASIC or whatever. Discuss.
So I don't know identities at all. A reference would be wonderful. I'm certainly amenable in the spirit of compromise to something that includes something simple as well as boiling the ocean.
I'll find you the reference while I'm, so
I am next in the queue, so I'll jump in. I like the idea, Tony, of keeping the model simple, maybe in the base model, while allowing for some flexibility to expand definitions as using identities. And then for the cases where for the particular device that might have more than one state, meaning as he mentioned the example of the optical devices maybe having a low power mode and high power mode. Let that particular piece of the model be expanded for those particular. I think I like the idea of keeping that flexibility in place using identities.
Rob, it's great that you're taking notes, but mute when you do.
Rob,
I think
it was me, yeah, not Rob. Let's not blame Rob because I think it was me.
I think simplicity is critical for this to be usable. It's impossible to write a controller software that's trying to do power saving if you have to know about every type of device, every vendor in that space, and every version of that vendor, as I'm well aware from other areas. So keeping a model that is somewhat distanced from the operational complexity in the world is a good thing, and I think that's in some way similar to what Tony is saying. It's impossible if you have to care about all the details. But this low power and high power mode, this sort of problem for me there is to what does those things mean? Okay, we can of course write a lot of interesting definitions, but who's going to meet exactly those definitions in their implementations later? It's difficult. It will be something high power-ish and low power-ish or something like that, and that would be difficult to the controller to know what to send this device if we have that sort of thing. I would prefer a sort of opposite model. The controller says, these are my requirements. Go do your best thing with this. I need you to send at least not 10 megabits or 10 gigabits, but 1 gigabit is enough, as long as you can return to full power in 500 milliseconds. And that's the other thing that's missing with this high power and low power. Okay, it's low power right now, but when can it be high power? That's a critical factor for deciding to go to low power. So we need this sort of timings or other transition parameters to make a decision.
So I'll ignore, I completely agree with, but I'll ignore the issues about timings and things. I think that's a good one. We should add that to list to talk about in a minute. In terms of keeping it simple, I can understand where you're coming from in terms of devices and having it generic, but it feels like an on-off is too simple in some cases, although equally, I can also, I sort of struggle to understand in some senses, most devices will run using the least power that they can. I don't think many of them will burn more power than they need to achieve their goals. I think that's fairly standard. I think that, I think in some devices like Ethernet, I know that Ethernet interfaces have a low power mode that they run in. Certainly the copper ones, maybe more than the optics ones. But again, I don't know. My Ethernet knowledge is a bit out of date. I don't know whether that's just something that's just enabled by default and you just get it for free and nobody would ever try and turn that off or any reason to turn that off. So there are some nuances from that perspective. I agree with you, Jan, that we don't want the case where every device chooses to model this a different way. So, and that is a risk with identities that you can derive further ones. But it was more the behavior of turning off a line card versus reducing the number of forwarding planes you've got active from, say, 5 forwarding MPUs running to, say, 3 to reduce power. That might be something that you can't model so easily.
My point was that if you tell a device, you go and save as much power as you can if it's okay to reduce the performance by 90%. Some devices might not implement anything there and they're still compliant, and okay, they are not saving any power, but I can still tell them what to do and they do nothing. But some other devices might have a half power state somewhere in the middle that they can leverage in this case. Some other devices might have 4 different levels they can see, oh, actually the next to lowest one can work for me. I don't want to know those details. I just say, these are my requirements. Right now it's night, so I can relax a bit. And you go figure out what to do. I don't want to know.
I guess to what extent? Because what we're talking right now reminds me a little bit somehow what I have heard when people were proposing intent-driven whatever, because at the end we're talking somehow about my intent regarding energy consumption, etc. I guess that in these cases probably would make sense that the control space is limited, but you can measure. What I mean is that the idea is that if we assume that there are 3, 4 maximum modes in which you can put a device, depending on the nature, full consumption, medium, low, and off, that could be it could be a rough classification. Then, I mean, on the other hand, you have for sure the characteristics of the device as they are published by the manufacturer. Say, well, this device, when it's in low consumption, doesn't evolve this and that, and this is something that is an information that you have that is not necessarily part of the model, though it could be part of the inventory. That's another story. And then you have the possibility of measuring. I mean, I put you in low state, and I wanted you not to consume more than, I don't know, 6 joules or whatever, and you are consuming 8, so I'm going to switch you off. But this is the way we are not, I mean, we have a mechanism for identifying a few modes and associate these modes with something that is described. And then, well, it's about, it's always about, which is always verify, never trust, always verify. I put you in a particular mode, and then I want you to tell me the consumption, or I have means of measuring the consumption. I think that combination would be the most reasonable I can think of.
Chin, do you want to discuss the identity you mentioned there? Putting you on the spot, maybe?
Yeah, just give an example. Yeah, I think we already discussed model design. I think using identity, is a good choice. And so we in our chapter we did provide the example. Don't limit how many identity you can define, but this is I think choose identity. Is a good choice actually. And also for power control, actually, I think we can break it down into two levels. We can have a centralized control, we can have local control, and so the low control maybe give the network device more flexibility to to do its own control actually. So I think yeah, I think yeah, introduce the intent idea actually align with this this kind of breakdown into this centralized and localized actually. Yeah.
Marisol, yes, just jump in.
Yeah, just one comment. From identity perspective, we need to kind of enumerate, right, the different states that for power, and this was one point of the discussion we had as well on the framework, where we are not sure if we should go for the different IANA types of power states, or just leave it open or put a range there. I guess this needs to be kind of addressed before we go for the definition of the data model for the identity on a power state, right?
Well, I think the goal is effectively to try and solve that question for both of those things. I think that's what we're trying to converge on, is to know what we should be modeling. And again, thinking about the IANA states, they are very granular, I think, and I know there's different definitions in terms of the EMAN model, and I don't know how you necessarily apply those, or how vendors would apply those consistently. So even if you see like a power range of 1 to 100, or I think somebody might suggested that, I don't know what it would mean to say set the power setting to like 75 versus 55. What would that actually mean in terms of traffic? What would that actually mean in terms of power saving? So I think it'd be really hard to know. And again, that in the identity, the IANA states, where all the different sleep states and sleep cycles and things, I'm not sure how relevant that will be to the people consuming this data. I don't know if that's sort of too much granularity to be useful. It might be sort of from a debugging perspective to know whether the device is sleeping or fully powered or some intermediate state. That might be interesting, but I don't think that's necessarily the core thing. And when it comes to the control side aspect of this, to whether you want to turn something on or off, I'm not sure you want to give that level of control to the client to say, I want to put you in this power state, because the vast majority of devices, I don't think, would normally have that level of control. like even if you think of like the Windows machines and things, you don't have the ability to put them in those power states. Normally you can tell it to sleep, to hibernate, to be off, to be on. But it will also move into different power states over time, depending on if it's idle. And so it comes back to the discussion point of whether, that's what Jan mentioned in terms of like the time-based thing is, if you tell the device what the requirements are, it's like, this is the requirements, what you need to meet. It then takes the choice as to, okay, well, I know I can shut off this port because I know I've been told it's not critical. And as long as I support this bandwidth and as long as I can come back in this time, then that might be acceptable.
I like the approach that Jan mentioned, right? Living on the controller side to tell what is expected. Even if the device cannot answer, that will be a default state, or a predefined state. But you give the flexibility to the different vendors to, and legacy will be included here as well, right?
Tullus.
Yeah, so I think the answer is maybe on both sides. So you're right. There is not that much you can do in Windows because that's optimized for kind of users that are expected to have a nice experience. On the other side, there is a humongous amount of nerd knobs in Linux, and I'm pretty sure that these are extensively used and optimized by a lot of Linux user community, not the least in data centers, for example. And I think if I look at typical users of routers, they also, range from the I want everything to run without me having to bother, maybe on the enterprise side, over the nerd knob heaven that you see in the service provider side. So maybe there's a way to, just create hooks in the Yang data model where to put, the nerd knobs underneath, and that may not need to be standardized, but there may be, examples given as a compromise way to kind of have nerd knobs if the vendors think some customers need them, but not have us bother more than minimum necessary about them.
Speaking for the service provider market, we would actually like to eliminate nerd knobs as much as possible. And that's also true coming from the service provider customers. Management of devices is becoming so complicated that people find it extremely painful. And so the more things we can make automatic, the happier people will be.
That's certainly nice to hear. And I've heard that for decades. I haven't seen a lot of that happening, especially because just, manual use of nerd knobs has been replaced by controllers setting the nerd knobs, right? So that is the type of automation we're currently seeing.
And we're trying to do better.
Yeah, but the cost of actually putting useful automation in a decentralized fashion into each device locally is a lot more challenging than doing it through the controller. And the controller uses the Yang interfaces to automate.
In the service provider market, controllers are the exception, not the rule. So we have to have distributed intelligence anyway.
I think for that last one, actually, I wonder whether we're going to see a lot more controllers over time. I think that is likely. I do have a lot of sympathy for Tony's views here, both on I would like to see the configuration models get simplified on devices. I think that there's huge amounts of complexity, and the more that we can simplify, the better. However, I do see examples in the new protocols coming along where there's still a lot of complexity being added in terms of what's in the service provider market as well. So I think it's an aspirational goal, and I think we should try we should try and do it as simply as possible. Certainly in any sort of standard model that we standardize, I would aim for the simplicity first. And then if we need to extend it with more details, then either we try and standardize those if necessary, or we leave that down to vendors. Emil?
Can I just
Yeah,
finish up on that point that we're having a working
who is
group.
speaking?
Sorry, this is Charles speaking. Sorry, just to finish up.
Yeah, go ahead. I will speak after.
Yeah, that point that we have a working group called Anima that is, giving a platform in the IETF for distributed automation intelligence. And, I haven't seen, service providers being very adamant coming forward and doing that, right? So if there is automation that is proprietary within a particular individual vendor, then that's not going to be very helpful for the decisions that we're making here in the IETF, right? So I would make the strong argument that we shouldn't trust on, distributed automation to be something that is happening unless we actually do something about it, whatever way we do it.
Okay, so I want just to highlight that before taking some decision, the controller must understand the capability of the device. And so what we have been discussing with Benoit and the people of who co-author the use case document is that there are different power states set. And so from my understanding, the controller must understand this set of power states before taking any decision, you see.
But I agree with that, but I think that the general point that we have, there is a long queue. Sorry.
Speak louder, Diego, please.
No. I was saying, I mean, I did not notice that Tony and Rob were on the queue, so I will follow the queue. Sorry, Tony and Rob.
Feel free to jump in, Diego. It's fine, I'm sure.
So speaking to controllers in the service provider market, they're very much the exception. They do not seem to be growing. People have been trying for 15 years, I think, trying to deploy controllers, and they've been suffering from scale problems. They've been suffering from implementation issues. The only people who seem to be successfully deploying controllers are the intersection of service providers who have large programming staffs. Might also consider these to be the hyperscalers. And again, they are the exception. Most service providers have more lawyers than they have programmers. And so controllers is very difficult.
Just let me say that hurts because it's true. Rob.
I was going to comment basically back to Turles on Anima, and I don't think that what I'm pushing for is saying we should do more of like an autonomic control plane. I don't think that's the thing that needs simplification. I think that netconf yang is fine, and I think there's other ways that we can solve that without having sort of distributed management of devices in that way. What I'm pushing for is, in terms of the data models that get defined and the features that get defined, is can we try and simplify those features so that we need less setting of particular knobs and features and tweaks and things? Can the protocols themselves be simplified in terms of the default settings for these things is just the right choice, and the protocols will just do the right thing, and hence the use of where you have to tune something or change a timer is very rare, rather than it being like the default thing that different ISPs run all the different protocols at different timers. Is that really necessary? And again, maybe rather than having a different like hold time and keep time, say what your time is for in terms of how quickly you want to be able to respond would be better, reducing 2 timers down to 1.
Well, Tony was making the argument that there are, decentralized control loops, and I haven't seen those actually being discussed anywhere. And when you're saying there are the Yang models, and the Yang models aren't exposing what needs to be controlled, I'm just lost here. What you're talking about, right? Also, the fact that controllers are being used, the question is really what you understand of a controller, right? So, I mean, every major service provider with large networks has a traffic engineering backend infrastructure that regularly updates the routing policies to match the traffic matrix, right? Mobile networks are even more complex with respect to dynamically updating through centralized or decentralized control loops, the size and shape of cells. So there is a lot of mostly centralized control logic. And if we're expecting to have any more intelligent optimization of energy consumption, if we just simply wiggle and say somebody somehow will, automate that and make it happen, I don't think we're doing our job.
Anyway, I think that the problem here is, I mean, we are starting to talk about, let's say, design decisions for a particular for a particular scenario in a particular network service provider, and probably this is we're going to find in the sense that ideally we should allow for decentralized and centralized, or well, small or big control loops. That's up to the is a decision that corresponds, I would say, to the kind of policies, the kind of customers, the kind of even devices that users have. I think that it would be dangerous if we assume that it's going to be only one single central controller per administrative domain, or the other way around, that we are going to have very many small control loops that will coordinate somehow. What I believe is important here is about the amount of information. I think that we all agree that whatever the control loop, we need a controller. That's something that is whatever the size of the control loop, and that there is an amount of information that must be in the controller, so it makes appropriate decisions about according to policies or whatever. It's difficult to me. It's difficult to keep this to push that down the stack to the device to do whatever they want. And I think that the reduced number, these identities that Rob was sharing on the chat, whether we choose this particularly this or not, is something that to me makes sense in whether the kind of control loop that you have, whether it's very huge or it's very small, is something that the meaning of the granularity of these states is going to be different depending on the size of the control loop, and this is something that it will be adapted in the particular deployment scenario. I believe that this kind of mechanism is the best we can go for facilitating an open control on the one hand, and the possibility of different design styles on the other. That is, I believe, is something that is important as well.
I do agree, right? But to me, that means whether I have a centralized controller or I manage to build local control loops into network devices themselves, I still need to be able to expose in a standardized fashion the control parameters, right? And if we are having more and more of an evolution of power consumption being achieved to rather, under the hood complex control parameters like we actually do see in more CPU-based systems, then we can either try to expose them in our Yang models or just hope that every vendor in a proprietary fashion, without us even being aware of it, doing their own thing, and hopefully that's sufficient. And I don't think that second one would be the better approach.
So I have to disagree. 95% of the service provider market does traffic engineering in a decentralized fashion, and they show little to no inclination to do anything else. Of the folks who are doing things with controllers, again, the hyperscalers, they are finding that the concept of a single controller per domain is intractable. First, for redundancy purposes, second, for scale purposes. Controllers can only handle so much. And so there are large classes of people who are trying to stay decentralized. So it's fine, you know, I'm not trying to have a war here about which way the world is going to go, but let's at least have the model support both.
Yeah, I think we agreed on that. So I don't think we agree on the classification that you're giving about, you know, most is doing what and what, right? So, but even I was saying, even if we just have a local control loop, we should still have the necessary control parameters extracted, exposed through our Yang model, so that we could use the Yang communication even for a control loop instead of purely hoping for some proprietary solution for the control loop.
Nobody's suggesting anything proprietary.
Right, but then let's say
the control loop is something called an IGP. We've been using it for many decades.
No, but okay, forget about IGP. That would even be, you know, in the network. But if I just have a local control loop in a router itself that can set some of these strange control loop knobs about, you know, how much, what power state the forwarding engine or the router should be put into, and I'm doing that based on my observed load locally, right? I could do that in proprietary fashion, or I'm exposing these different control states of the NPU and the CPU through our Yang model, and then whatever local script is being developed by whomever to do a local control loop is using IETF standardized Yang model.
Can I just jump in and ask a clarifying question both to Tony and Tola? So one way of doing this, Tony, I think you've said simple on and off. Jan mentioned doing basically setting constraints, as in I needed at least this amount of bandwidth, and at this point in time, I need to be able to go up to a high level of bandwidth within 1 minute or within 30 seconds. So that's a second choice. And then Turles, you're effectively saying you want finer level granularity in terms of, does that mean you want to be able to say, I want to be able to set the forwarding plane to be like running 60 capacity rather than 100% capacity, or I want to tune down the fabric planes from how many to half the number? Is that the level of granularity you're asking for? Is that the difference?
I'm saying that if we're coming up with two, you know, intelligent parameters that nobody exactly knows how to implement across all the devices, then we're just creating stuff that's not going to be implemented, right? So if we use the actual low-level parameters, then we're creating bad nerd knobs, right? Nobody likes them, as Tony said, but they may be necessary in the start to even get to proof of concept of more abstract representation of the goals that we're intending, right? And my compromise proposal was to say, yes, we need these nerd knobs to get any control loops built, however they're done locally or centralized, and over time we'll be able to figure out, okay, so we do see enough evidence that the better abstract you know, intent type of objects in the Yang model can be realized, so now we're defining them.
So again, I just wondered if you set if you consider this the fabric, you say I'll need like 50% of what the fabric capacity of the device is. That's what I require, and that's what I need. And I need it to be able to go to full capacity within some time frame, 30 seconds. The device either says yes, I can meet those constraints because I know I can bring the other fabric planes up with that in time, or I can't, and I run at full fabric. Is that necessarily that different from be able to turn off two of the fabric planes itself, or half the fabric planes?
Can you repeat the second part?
So the first one is sort of intent-based, saying this is I'm setting these requirements. This is what I need you to be able to do down to the device, and the second one is saying these are the actual steps you're going to take to meet those requirements. But they sort of end up in the same place. The first one means a device. I guess there's more logic has to be put on the device to figure out how many fabric planes you can turn off to meet that. But again, it's not it's not particularly complicated in that sort of modeling. There may be other examples.
If we feel very confident that the more abstract intent-based model can always be done in a local fashion in vendor code without any more exposure needed to troubleshoot and diagnose it, then perfect. Then we use the intent one, right? But I'm saying that if we're unsure exactly how this can happen in different devices, then I think we may need to expose the lower level options and to allow people to start experimenting building the control loops.
One last comment, and then I'll go back to Tony. So just to say, is the interface to the configuration in terms of what the configuration is and what you report operationally to say what state it is, they don't have to be exactly the same. You can augment extra operational data in to say this is the exact, I've turned off these fabric planes. So you can see what the action is.
Yeah.
So I agree completely. Stating requirements is a fine idea. If you look at my draft, one of the things we do require is, what is the expected bandwidth on this interface? That's a simple requirement, and that's easily implemented. As to the nerd knobs, the problem with the low-level nerd knobs is once you start implementing them, everybody wants their own. And pretty soon we're going to be awash in a sea of nerd knobs. That's not a happy place. Having requirements for bring up is a much slipperier slope. How long does it take us to come bring up an NPU and then load it with the full fib? And this is very much a scale question, and this is not something that's trivially answered even on the device.
And so what would so actually I'll come back to Jen Chen because he's been waiting in the queue for ages. So what would be your proposed compromise then, Tony? How would you suggest solving that? Because if you don't know how quickly it's going to come back, you may not be able to meet your SLA requirements.
I don't have a very good solution for this. I was trying to deal with that out of band completely.
As in between the operator and the device vendor, you've agreed what the time constraints would be, how long it would be based on the scale that's actually being used on the device. Is that?
Exactly. The controller has to work sufficiently ahead of demand so that it can power things up and do so in a reasonable fashion before the demand actually hits. And how long that's going to be, again, it's a function of scale. So, it's going to vary based on network and size of fib.
Okay. Jen Chen, thank you for waiting patiently.
Yeah, okay, thank you. So in my opinion, there could be control loop automations on the controller side for sure. But the main question is that, in my opinion, the controller still needs to understand or to discover the capability of the end device. Because there could be different capabilities, different power saving modes with the end device. How could we know they're operating correctly? Because with the expectation of the controller, there are, some high level description that's related to performance requirements. And it means the end device may not operate in ideal mode. Maybe there's a firm mode with the device and it should operate in the first mode, but actually it's operating in the second mode. So in this way, we need to discover the faulty behavior of the end device. That's why we need to know the capability of the end device. Thank you.
If you want to augment your device models so that you can expose all of the states of your particular device, there's no problem with doing that. But trying to be that specific across all devices within a single RFC is going to become an encyclopedia.
Totally agree, Tony. If I may, let me insist. I believe that a reduced number of identities, like the ones that are being shared by Rob, is I mean, in my view, the reasonable compromise solution between this encyclopedia Tony is concerned about and leaving everything in the hands of the device to make a wide interpretation of what the intent of the control is. For sure, these 5, 6, 4 different states would be translated by the device and would be described in their description that will be available for the people programming or controlling the loops. But we have a set of minimum with a number of states that can be generally understood and with the precisely part of the describing the feature of a particular device would be to describe how they map to this small number of potential power states. So, sorry, Teng, I jumped over. I noticed when I was in the middle of my discourse. Sorry about that.
Yeah, I agree. I fully agree. So we need, because all the power saving modes or power saving status, power mode, power state is related to performance and other metrics. So we need to know the capability to understand whether the device is operating in the correct way. And for the specific state, there could be multiple states, but as Diego mentioned, there could be some abstract summarization, such as on-off saving mode, or high-level saving mode, or deep-level saving mode, or slight-level saving mode, etc.
So if you want to know if something's operating in the correct way, either it can give you back 1 bit and basically be an idiot light, or it can come back and give you JTAG access. Which is it you want?
I'm not sure I want JTAG access. That sounds like that'd be too much. But I think that adding different states and reporting what power levels something is in is okay, because that's, as long as there aren't too many states and as long as everything can map onto those states. But I still wonder whether you need to know how much, whether you need to know it's on a deep power state or a not so deep power state. I wonder how helpful that is. And it may depend on the networks and things like that. So it may be that in mobile networks, where you're talking about radio networks, that might be more useful. So that might be a difference here versus core networks and things like that. So again, that might differ, but I think that just an on-off flag is too little, and I think JTAG is too much. Right, so I've now lost my screen. Can you still hear me?
Loud and clear.
Okay, while I try and find where my window's gone and come back to that. The question is, do we want to carry on discussing this issue? If so, I can try and summarize it.
So maybe as one helping point to answer that question, if we go for the intent route to, as the only IETF standardized way to set actually controls, then the question is, do we have all the necessary intents, right? One of the big benefits of setting the nerd knobs is that the reasons why you're setting them may be very varied. And so you can have a lot of different intents to set the same nerd knob, and you can then program the control loop to do that. If we only expose the intent, then we need to make sure that we have all the necessary intent there to trigger underneath the nerd knobs and make life simple.
But I guess that in any case, those nerd knobs, if there are that many, can be subject to augmentation or things that are not necessarily part of the standard. I mean, that's something that you can have for sure, and probably in some cases they might be interesting. Let me insist, if we try to bring a solution that is wide enough and open enough, I would say, in my view, is this idea of a few power states is the way to go. Start from that moment on, gain some operational practice, see what happens, and then even we can go for a purely pure control for the from the side of the device with some hints provided by the control entity, or the other way around to a much more detailed one. But I would say that this intermediate solution would allow us to gain the much required operational experience.
Right, but that's what I was proposing, that we basically say if we feel things proposed here are too nerd knobby and too much encyclopedic, as Tony said, then let's at least make sure that we explain sufficiently well enough how to do those things through augmentation by providing these attachment points where you can do vendor-specific augmentation in a structured way, as opposed to let them try to figure it all by themselves.
Okay, so we are on the same page. Sorry for the misunderstanding.
So given where the discussion is, I was going to try and summarize. I think I'll need other people's help here because the conversation has gone into lots of different directions, and I think we've got some consensus over some things, but not necessarily everything at all. What I'm hoping is if we try and get agreement with what the summary is, that we can then, and maybe I could try and share a screen. We could then ask Jan, hopefully throwing Jan under the bus here, whether he could actually perhaps put some data models together, some examples to show what this is like, and then we could actually have a concrete discussion about what it would actually look like. And take it from there. So just before I go any further, Jan, is that something you'd be willing to try? Do you think you would have enough information?
Yeah, I mean, small sketches like this, sure, I can try something, absolutely.
Because I wonder whether that will also be helpful if we start to have some specific examples to discuss. So the summary I've taken out, I may have bits missing, is it feels to me like we want to be able to support both controllers and like distributed control planes, that there's a need to be able to do both. I think that's come across, that we don't want to constrain it to one solution or the other. I get the feeling that we want to at least be able to support a simple model that can be extended. Now, Yang, you can augment anywhere, so any model can be extended, but I think Turlis's point is that would either need to be advice on how you extend it or some guidance to sort of rail that in a bit. I think that's okay. We briefly mentioned things like bandwidth requirements for interfaces, but there's also other nodes that could apply to. I think it'd be interesting to see what that might look like in a model. I'm not sure we've got consensus on that, but I think that would be good to see. Jan had mentioned, and maybe we should discuss this a bit more about in terms of setting constraints on when it'll be able to change state again. Tony's saying that's too difficult to implement. Again, I think I'd like to see what that looks like. But again, it might not be a modeling issue. I think it might be an implementation issue in terms of modeling. It might be quite easy, but then actually finding out whether that's implementable, I think might be a more critical component. And the last comment I'd made, I think is probably worth capturing here, is be able to split between config and more complex state. So I definitely think having the configuration simpler is more important, and a simple way of reporting the state, but you can always add extra operational leaves into the data model to report a bit more detail about the exact state it's in. I think that's fine. And maybe in some cases for reporting operational states, perhaps the existing EMAN states might be appropriate. I don't know, that's a separate discussion. And lastly, I haven't written it down, but I think it's worth, I think that Jen Chen's comment about capabilities is a valid one. There is already a capabilities Yang model that allows you to express some capabilities, but I think that is something we should think about here. Because of the way that data model works, it allows you to express the capabilities on either very coarse way or quite granular way. You can say for this particular path, this object, this is the capabilities I support. So that's something I think is worth thinking about. Have I missed any large things from there? Have I misrepresented the discussion? Comments now.
No, very good. It just wanted to add that the augmentation is easy. Kind of was not what we experienced in Anima with RFC 8366. If you remember, when you were AD and we had these discussions in London. So I do very much like to run an explicit, test in theory in terms of for the augmentation to know the stuff will stay backward compatible. So it was painful.
I mean, yes, to that point. I mean, when you augment, you obviously can't change the data model. So you can't change things from like a container to a choice case statement, for example. So the data model needs to be designed. And again, although you can augment onto groupings, the augmentation is done at where the grouping expands to. So that can be quite painful in Yang.
We don't need to drag it out here, but I mean, we had pains in the IETF with bizzing data models and trying to have multiple RFCs doing augmentation to the same base data model. So there's still a lot of complex issues that we haven't very well solved, and so I think it's good to be aware of those, and that's why I was saying let's think about that.
And the other thing I think is worth considering here in terms of that is that I know that the IETF's approach to data modeling has been to try and get the data model right before it publishes it. I think with Yang, and certainly with these things, it's quite hard to do that without getting the operational experience of using those. I do think in the early days that the open config approach is arguably a bit better, where they are more willing to accept breaking changes and move the models along. You just don't mark them as stable for a while. You mark them essentially as experimental for the first few years while they're being developed. And then when you've got the experience, say, yes, we think this is good enough, then you lock it down. So I would encourage that sort of approach. And hopefully IETF might move towards that direction in the future. So I've tried to summarize the issue summary in the chat. I will put the link to the chat here. Please, can you check that you're happy with what I've put? It's right at the bottom, issue summary. And then I suggest that we try and tackle another issue today as well. And that's not to say this one is closed and done. I think that we will have to come back to it, but I think we've probably got as far as we can today. So putting the issue list back up, is there another issue we would like to discuss? If not, I'm going to suggest maybe like 8 or 9, the accuracy of the data or the time intervals for data reporting. I think those are both interesting ones to discuss as well. So I'm going to go to accuracy of the data. So actually, is that the one I wanted? No, just go. I've got accuracy on here. So I'll go on to this one, so question 8. So this one was one I was thinking about, is that do we define accuracy in the data model to say we're going to report, like, for example, like power consumption. The power consumption you might want to report for an entire device might be in the range of kilowatts, and hence your accuracy to that might be 3 significant figures might be sufficient. And that differs from, say, the power levels you might want to be reporting on optics, which could be in the watts or milliwatts levels. And so we need to think about what we do in terms of the data model, whether it has the sort of level of accuracy that's being reported. And it's worth noting that normally floats or doubles would solve this problem very well, but Yang doesn't support these. We don't have that choice today. You can overload floats and use like binary, but that's not particularly nice. So there's something that's sort of something worth thinking about there. I think there's question marks about if we try and define these in the models and devices can't meet them, what does that mean? How do they report it? And then I think we need to think about the clients that consume this data. How much do they care in terms of the accuracy of the data that's being reported and how you do that? Or do we have the data models themselves be able to say, this is the accuracy that I'm reporting this data to? But that adds complexity to the data models. So that's some of my thoughts of some questions we should think about. Any thoughts, comments? Marisol? Can't hear you speaking. Are you still muted? I still can't hear you.
Yeah. Looks like you have something. Marisol, if you feel like probably if you can use the chat, something at least we can record your views on this in the minutes.
We might be to somewhere else. So Tony, do you want to go next while Marisol's trying to figure out her audio?
So this is a messy area. You're absolutely right that having 3 sig figs is probably not helpful, and more importantly, it's not going to be possible in a lot of cases. Actually understanding exactly what power a component is drawing at any one moment does require some circuitry, and not everybody's going to install that circuitry on every component because that costs money. So in a lot of cases, the only number you're going to get back is something that's hard-coded into software. And that's about the best you're going to get. And I think we have to allow that. So I think that the answer for all of this is best effort.
But besides best effort, you can also have some device report how accurate it is. It may know that it's gold, silver, or bronze standard quality data.
If you want a separate field that delineates how many sig figs you're providing, that's fine.
Yeah, not necessarily exactly how many figures, but sort of classes, like I said, gold, silver, and bronze, or something like that. Just like you have on resistors in the old days, you had a gold ring, silver ring, bronze ring, or red for really accurate things. So you have some sort of classes.
That would be fine. I'll point out that those colors were closely associated with absolute accuracy percentages. I would prefer something accurate rather than somebody's abstract definition. There's some sustainability stuff that classifies buildings, and that gets very murky very quickly. So I would prefer something quantitative rather than qualitative.
Sure, we can certainly agree on what the definition should be for those classes.
So I mean, this isn't the first time that we have these problems, right? So my longest reaching pain point has been with, operational counters, that were exposed, through MIBs. Don't think anything has improved with Yang, right? Where, you had to ask the vendor, well, how often are these counters updated? And then you get answers like, oh yeah, so something like maybe around once every minute, 20% of the input is changed. So all type of complex answers that, describe the accuracy of those counters. And, I would say, given how we survived for important things like, traffic stats and other things with these really bad solutions, maybe the best we can do is try, to go back to, I'm trying to remember who proposed it, that capability model, and try to come up with examples of how in the capability model to express the behavior of, such reported data. But, just with the reported data itself, go ahead, as we've always done, have they some random accuracy. But yeah, try the, capability model to express the accuracy, because I haven't even seen good examples of capability reporting for those properties, right? Because it's not the simple E-man thing that they've come up with, which is, oh, you have an energy and the accuracy is plus minus 5%, right? Because that already is a really bad abstraction when you're saying that, oh, this data is 100% accurate, but it may, not be accurate in time because it's sampled once every 10 seconds or so, right? So that's the complexity in the accuracy, where, let's outsource it to some side effort like the capability model and come up with examples of how it could be expressed there.
I mean, one thing I was thinking about here, and this was coming back to a comment Tony made about like reporting static values, e.g. for, say, the optics or something, then the risk with that is that if you are measuring both those power levels from the optics for each interface, and you're also measuring it from the line card or aggregated across the device, and you sum up all the totals for all the individual components, and then you compare that to the value of the devices. If the components draw more than the entire device, then you know something's wrong. Or if they draw significantly less, you end up with quite a skew between those. And I don't know how controllers will deal with that sensibly. I don't know what the solution to that problem is, but that is one concern I have in terms of, yes, you can report the accuracy. I think you need to have some way of knowing if a value is definitely, if it's hard coded or dynamic. I think that would be important to report, i.e. you're reporting actual power usage versus you're reporting something from a data sheet would be good to know. But to Jan's point, even if you're reporting accurate power, I think there's a wide variation as to what accurate means. I think that's hard to report. I think something they've hit.
I mean, the hard reported is just one case, right? So in the other cases that you were saying, there is kind of more or less intelligent software that tries to approximate it indirectly, right? Because you don't have as Tony said, the explicit measurement hardware to do it correctly, right? Or you're sampling it, as I said, and then there is a time skew creating additional. So yes, there are all these different type of inaccuracies, and I don't even think we have even written down those different cases of inaccuracies, right? So even getting to the point of, you're making a conclusion, oh, for this one particular subcase like static, I would like to have that reported. Well, let's where is the list of all these possible cases of inaccuracies in the first place, to then do the next steps, right? Have we written that down? I don't remember that we do.
No, but does the client need to know all of those? So the question is how much what's the client going to do with the data, and in terms of consuming it, and let's try and sort of categorize it in ways that the client can actually act on the data. Because if there's lots of categories that end up being the same thing and the client's consume it the same way, it doesn't sort of matter whether the inaccuracy is because of A, B, or C. It just matters how accurate the data is.
Jan's previous suggestion of reporting accuracy would be just fine. It gives us reasonable ways of dealing with this. Being able to say this is plus or minus 5% or plus or minus 10% is pretty reasonable.
Yeah, again, the percentage stuff is what E-man did, and I don't think that helps a lot because there is the timing. So what the E-man model does, and what math does, is just the value instantaneous. But there is also the question, what's the accuracy over time, right? Which is the sampling problem, right?
Well, these classifications could take that into account too. So the bronze class says, yeah, this is a sort of more or less accurate number within the last minute, and the gold one has a stricter. It's up to date within the last 2 seconds, and it's within 5%.
Well, the difference between instantaneous inaccuracy and the sampling-based inaccuracy is that whoever is trying to analyze the data does know when there is a time-based inaccuracy that it can only, provide less, sampled information over time, as opposed to just, for every point in time having an inaccuracy, right? So it's a big difference, and I think that needs to be exposed.
If you would like to expose the sampling rate, that would be not unreasonable.
So, sorry, I was typing at the same time I was making notes. So I had separate one on, so we can jump to that briefly, like what time intervals is data being reported over? Because again, I think there's different implications as to whether you're trying to report an instantaneous power usage at that point in time versus you're reporting aggregated power over time. And then the questions on this is, does each component allow to use its own time interval, or are these predefined and fixed? Or is there a standard set of these? So I think this is another gnarly problem that we need to figure out what the best way of doing this is.
Why wouldn't you allow this to be reported per component?
The concern I had there is if you allow each component to do it, so if one of them does every 6 seconds and one of them does it every 5 seconds, when you are trying to aggregate that data together, it makes it that much more complex. Whereas if they're all said, actually, you report this every 5 seconds, then it makes it easier if you're writing into a time series database, so you know what the same bucket size is. So that's the concern I had, is if you allow every component to report over a different time interval, and it's not instantaneous power usage, then it makes it trickier.
Well, if, for example, you would, for every reported data element, add to that data element a timestamp when that data element was measured, and you're building your diagnostic software that's trying to do it, and it figures out, oh, wait a second, so all the data that I collected is spread out over a period of 2 or 3 minutes, then it does know how to represent something with a time, averaged over a period of 5 minutes, right? If you do get all these things you poll the system and you do get updated timestamps for all of these things every few seconds, you paint a totally more time accurate picture, right? So adding timestamps, we've done that in counters and other things, right? So is one option. Would I want to go all that way complexity? I don't know, right? So it's really a difficult space.
Even if the time intervals are the same, it's actually quite difficult, because you can, even if 2 components both report at 5 seconds intervals, it may be that it's 5.01 sometimes and 4.99 sometimes, and you might miss and get double counting, double 2 in one interval and 0 in another. It's not easy, no matter how you do it.
So
well, that's more with
the
counters
point.
than I think with energy levels or so. But you're right, yeah.
The point is, if you think about it, I mean, at least from an operator perspective, these instantaneous power usage, a peak in consumption, may be a symptom of other kind of problems, but it's not that relevant in terms of the power consumption. What we are interested when talking about energy savings, etc., and we're talking about energy savings in whatever the side you look at it, in terms of money or in terms of the impact on sustainability, nature, etc., is about something that happens during a certain period, because it's when you are consuming energy. In the other case, we're talking about more or less something that has more to do with the measurement of power, not necessarily of the energy consumption. That said, it is important that we find a way in which this is something that can be reasonably aggregated, compiled, etc. Whether it's that we mandate for certain intervals, that would be, or that we require that certain intervals are going to be standards, or that we look for a way in which the device can express this, and then an aggregator could take care of this. To me, it's not that much clear. I guess that mandating one single interval or a set of single intervals probably can be complicated in some cases because of circuitries and things like that. But certainly, this is. I do believe that this is something that would make the data usable in for the management of energy consumption and for other purposes. Like that, there are some of them listed in the use cases about aggregating the general energy consumption for a particular service, etc. So if we don't have the time, we're going to have measurements that will be, well, quite useless, I would say.
So some of that, like the time aspect, and even the point of time the data is sampled, I think can be solved through like the Yang telemetry protocols, like Yang push light or Yang push. So there you have a time interval as to when you're going to read the data from the device. You tell the device I want to read it like every 30 seconds on the exactly on 0, 0 and 30 seconds in the minute. And so although the data won't necessarily be read exactly at that point in time, it should be fairly consistent for those devices. And that may be sufficient for what needs to be gathered. In terms of, it could be worth saying both if you the ability to report the instantaneous power usage, you can do that, which might need some averaging, but also the total power consumption since time zero, whatever that means, might also be useful in the same way that you have interface counters today, and they're just reporting that they've received or sent X packets since the last time they were reset. You could do the same thing with the power. So you sample it every whatever interval you want, and it's going to report the power at that point in time, and the device can choose what level of interval it's willing to accept, and that may be a solution. So you're just reporting total power consumption since they were last cleared. Maybe that's an approach.
So just because you're using a fancy new protocol to periodically together export, all the data that you want to analyze or represent, doesn't mean that the way in this, how they're being sampled, created in the system has changed, right? So yeah, over time, you could say, well, the way we want them to be exported should have an impact of how they're being collected. But I think at this point in time, the best we can do as a start is to really expose the list of useful attributes about, what they mean, right? Instead of expecting that the implementations are going to be improved, that they all are, consistently sampled, consistently created. We do know that there are too many different ways to create them. We can't expect them to be unified, right? Some are mathematically calculated, some are sampled, some are hard-coded, right? Some are from the line cards, some from CPU. So I think the first step is really trying to find a good compromise in expressing the most important information about what the counters means, what timing, what percentage accuracy it has, whether it's static or so. These properties express them so that any existing implementation in the system can start with whatever data they have, just adding this Yang data model to it, and then improving, like I think what you were hoping for through better Yang push and others. I think that will come over time, because it may often require a lot of internal refactoring of software, which may be expensive and needs to be justified.
I'm not sure by that, but in terms of if you were just doing like get requests or show commands, again, you are sampling the data at given points of time that when you're making those requests, or the Yang push is moving that onto the device to push the data off, probably with some more accurate cadence. But you're still reading at a given point in time, and when you make that get request to get the data, you know when the request started and you know when the request completed, data returned back to you from a client perspective. So you know the time window that data is over, even though you don't have as much accuracy as you would in Yang push. And in terms of the actual counters themselves, giving the instantaneous, this is the basic power consumption, which is the same as like an interface throughput. And this is the total much amount of power that's been consumed by this component since it was last cleared or turned on. Those two seem to be the two simplest things you can report anyway, are they not?
No, so the power consumption, you obviously want to get over some period of time, right? Not since the device was being turned on.
Why? So like when the number of packets that you transmit through an interface, you generally report the total number of packets that have been transmitted or received since the device was turned on, all the counters were cleared. So, and then you allow the clients to then generate the deltas that they want. So if they sample the data every 30 seconds, they can then turn that into, this is the number of packets per 30 seconds. And the same with the power. If you're sampling the power at those intervals, whatever you choose, you can then decide to turn that into power over time or energy over time.
So the problem, right? So the problem with that is that if you're interested in the power fluctuations and you let the system run for a long time, then the absolute value of the aggregated counter that you have pushes out the accuracy of the incremental value that you have accumulated in the last 30 seconds.
Say that again. Tell us I didn't follow.
So the accuracy of the counter that you may so if you're lucky, you have, let's say, a billion counter and you're not losing accuracy, right? So in packets, that typically is the case. But if you're saying, well, this device uses a few watts or so, and then I'm letting this thing run for a month, and I've accumulated kilowatts, will it still be accurate to the delta of a few watts that I'm exposing through the counter? If it is, then yes, you're right. But we need to make sure that the aggregated still is accurate as to the full resolution of the incremental.
Why wouldn't it be accurate? If you collect samples that are plus or minus 5% accuracy, then the summation of those elements should also be plus or minus 5%.
If you do it in software, you're right? If you're starting to do, if you're using integer software, you're right. If I guess we can't do real in Yang, I'm not sure if the underlying software would do any of the energy calculation in real, right? So if because the accuracy there may just be how many digit is it, right? Depending on how you're doing it. And if you're doing it somewhere in hardware and you're aggregating in hardware, then there may also be accuracy issues.
I've got a different answer to Tony, actually. So I think the case where you gave of you don't actually know, so you're reporting like a power sheet value. So you say this optics is always using 3 watts, when in fact it might use anything between 1 and 3 watts. Then over time, even though the sample is, you have the same accuracy between the two, but effectively over time, that might skew much more significantly, I guess.
But that data point is going to be 3 watts plus or minus 50%.
Yeah. Right? Yes, and then so the final values is whatever it is, plus or minus 50%. Yes, that is fair. And I think, so for these sorts of things, again, for interface counters, I know that the hardware, sometimes the interface counters might wrap in 30 seconds or a minute, but you then normally have software that then turns those into either absolute counters or makes them robust and reliable. So I would have thought the same thing is required here, is that in terms of the devices we're talking about, that your software can do the aggregation if the hardware is not accurate enough, or the best estimate it can do, and the best estimate it can give.
Well, so the possible new issues under the hood are the use of float aggregation over time, if that happens, and the use of aggregation hardware, which may lose the accuracy over time.
But if you use floats or doubles, then your accuracy should be fine over time, as long as you just convert it to a long or decimal, whatever you happen to use in the AND model, and you don't carry that conversion error forward, then you'd be fine. So I don't see that's a problem.
But
and
I mean,
if
I look at typical hardware, where devices are aggregating their use hours or so. I mean, the accuracy of hardware to do to do energy consumption over time is sometimes really, really bad.
But but why is that different if it's sample? What I don't understand is if you are reporting the power usage every second, and a controller is aggregating that data and adding it all together.
If it's in software, you're right. All I'm saying was what happens in the hardware. The way on how energy, consumption is ultimately being done in hardware is, I think, beyond our experience point with packet counters and other data that we have done in the past. So I'm just saying we need to be a little bit more careful.
I'm still struggling with this. So ultimately, you get a value out of the hardware, either an instantaneous power or power over time, and everyone can build hardware that can add numbers together. That's not difficult. So I don't understand why this should be an issue. Why the hardware makes any difference? There's an accuracy in terms of how accurate the counters can be read, but beyond that, everything else is just a software issue. It's not a particularly hard one to solve.
Agreed. This is not a hardware issue. How to build a hardware power meter is very well understood. The only question is how accurate do you want to make it and how much are you willing to spend for it? And the answer will be no, we're not going to spend for it. So, don't expect great things. Nobody's going to accumulate these things in hardware per se. That's a hardware cost, and that's silly when you can have software do it. And that's what people will end up implementing.
Tell us, you're still in the queue? You got any more?
Yeah, comments? I was just trying to reconcile what we've been discussing with some power meter experience and so on. And it may simply be that the software that I've been seeing in power meters and others is worse than we should be able to expect good router vendors to do them. So.
Again, expecting high levels of accuracy here is probably going to be thwarted. People are hoping for 1, maybe 2 significant digits, not more.
Which is fine. I'm just paranoid in that if there are possible issues that might have us lose that accuracy.
And I still think that I'd still say we should try and write the simplest model possible, and start from there. Write what we and then say, okay, we found out this doesn't work, so we need to make this more complicated or complex because this doesn't work. We know the simple case doesn't work, rather than in any way building extra complexity into the model to assuming the simple cases won't work, and then you end up with a model that's so complex that it's difficult for people to consume or to even implement.
And we also know that humans are lazy. We know that we are going to get the cheapest, simplest, dirtiest implementation possible, and that no matter how we specify it, we're still going to get that.
We have AI to help us now.
I think we agree on most all of the things, and I would certainly not want to have any more complexity in the actual data reporting model. But I do think it would be lovely to have this capability model that improves exporting information about what the accuracy of the reported data is with or how it is collected, right? So that allows to ignore the stuff if you don't care. But when you do try to figure out why the reported data behaves in a particular way, you don't have to necessarily go dig with the vendors very deeply, but you may find it in the capability model.
Yes, and I'm supportive of some level of capabilities being reported or accuracy being reported for the particular field. So I think that's something that we should include in the models. I think that's something that sounds like it is important and has been considered by some of the models being proposed.
Just to be clear, I assume that we are going back to the accuracy of the power measurements. We're not talking about the accuracy time-wise, right? It's not that we're talking, because that's I would say that the accuracy here, let me say something that, well, if you can measure every 10 seconds would be the minimum here in the that would make sense. Probably we're talking about measurements that span 1 minute or several minutes.
Yeah, I think right now for all the power consumption, I would also say in the typical routers, the accuracy and time that we need for power stuff is certainly good over minutes. And I'm trying to reject myself and saying, well, what's the most important use case where we need it more accurate? And I think in many of the questions about power, we're missing out a lot of experience with the use cases to say what time accuracy do we need, right? So all the power metering that I've seen most of the time, outside of routers is in order of minutes, and hopefully that's good enough so that we don't need to bother too much about it.
Yes, as I said before, the only case in which I can imagine that something that in a much smaller interval would make sense is as a symptom, something else that might happen, and probably you may want to be informed of that symptom to taking any action. But in terms of the energy consumption, I don't foresee that would be the case.
Well, I mean, you do see a lot of those things in computers, right? So, for example, if hard disks are turning on, right, so that's huge power spikes for servers. Sometimes you're even looking at indirectly measuring CPU speed. So the more we're getting into that, if I don't know, we're looking at mobile networks on the edge that are running on servers, it's a totally different thing than the core routers in national service provider networks, for example. And I think we're rather thinking about the latter one as the first goal of this work, right?
So we're getting close to, we've got 10 to 15 minutes left, and it'd be worth having a few minutes to wrap up and give people a few minutes before the next meeting they have another one. So so for this one, I think the summary I have is it'd be useful to report instantaneous power. It would be good to report total power consumed since that component was last reset, or whatever you want to call it. I don't know, we haven't really discussed whether having one that reports the power over the last, like an average power over the last 5 minutes, is useful or not. I don't know, that might be possible. I think there's consensus to report some level of accuracy of the information being reported. So I think that has come across as a fairly key indicator. So that's the sort of summary that I have covering this one in terms of how frequently we collect it, and somewhat the previous one. I think one thing we didn't necessarily close on, again, on the previous one, is the size of the counters being reported. Like, is it in watts? Is it in milliwatts? Maybe we need multiple fields to be able to report those, and have a choice for a given component what it reports the data in. Do people agree with my summary? Have I missed any key points?
I will point out that OpenConfig decided they wanted watts, not milliwatts. I think that's something of a mistake, but that's what customers asked for.
I mean, what I was thinking, Tony, is you could easily have two operational fields, one in milliwatts and one in watts, and that would allow components that are reporting higher power consumptions to report in watts, and ones that are reporting lower to report in milliwatts, and without having to report everything in milliwatts. And then so any client would have to look at both those fields, and either one or both of them would be reported.
Okay, that seems like redundant,
but you, for given components, you don't have to report both of them. So it means that your router, for example, could be reporting only the watts counter, and your optics can be reporting the milliwatts counter.
But
Understood.
so if we're using milliwatt hours, which I think would be the worst thing, right? Because that's accumulating. Has somebody calculated when we're running with the biggest, device that we could have overflow? Because I mean, we can make it 64 bits, right?
64-bit counters don't wrap very fast, in my experience.
Right. So that's what I'm saying, right? So I would say, even if I don't see a lot of imminent need for milliwatts, right? If we can always use 64 counters, we're not overflowing. So why not do it? Because then we're safe if we go in the future to low power, mesh networks, for example, with our model.
Question, are we talking milliwatts or milliwatt hours? It very much makes a difference.
Yeah, I was trying to go with the worst case, which is a counter for milliwatt hours, because that's accumulating over time. If we're safe with milliwatt hours and feel safe, it will not overflow in the biggest energy consuming device, then I'm happy with milliwatts and milliwatt hours.
Wouldn't it be better if we just had devices report their usage rather than doing the integration?
Well, I thought that Rob was making the argument that if I'm periodically polling, then I do get a lot more easy data over time if I'm doing the watt hour, right? I'm looking at the counter every 30 seconds, and so I can easily do the difference, which was already integrated by the router itself. Maybe I misunderstood, Rob.
Yes. Well, I was saying that you can report. I was suggesting both. One is you report the total amount of power consumed since that device was turned on, and the second one was to report the instantaneous power consumption. So have the power usage. Those units for those two would be different.
And the instantaneous stuff is a lot more subject to understanding how it's being, calculated or measured or interpolated or something, whereas the integrated one would much more be the easy approach, right? I take it once, 30 seconds later, I take a new one, I do the difference. That's a much nicer approximation over the period. So yeah, I do like the energy consumption, not only the instantaneous value.
Okay, I prefer the instantaneous value. It's simpler to implement and more likely to be accurate. And if somebody wants to integrate it, they can easily do the math themselves.
But
Well, no.
I think
Why are you saying that the integrated stuff is more difficult to implement, right? You have internally, will always have the measured energy at some point in time. With it, you can have a timestamp for that, right? So the next time you're doing the same thing, you're making the assumption. So you internally know when you're taking energy measurement, so you can easily integrate over time.
The question is, do you want to do that functionality on box or off box? I prefer
I think
because you may not know out of the box, you may not know that, you most likely don't know the time when you did do the measurement unless we're exposing it.
We've already argued that we were going to expose either a timestamp or a sampling period.
I have to say, I think that the device doing the aggregation is likely to give you much more accurate information than you doing a sample and then taking it, because it's still hard to know exactly what averaging the device is doing to give you that sampled value. So I think that you might get a compound of errors if you sample the device and then try and add those together. Is my instinct here, but I don't know.
And exporting the timestamps, I mean, I tried to get that implemented for counters, and that turned out to be very difficult, right? So that's why I'm not sure that Tony's claim that, you know, being able to ask for the timestamps in the export is going to fly well.
So effectively, I think I'm going to cut the queue at this point. So we've got 5 minutes left. It sounds like there's still some more discussion on this one to be had. I don't know. So Jan, I sort of had half a summary, but then there was some further discussion on that. I don't know if there'd be enough for you to have a go at doing some models on this as a starting point, or?
Of course, I would put something together. And
okay,
you can
fine.
criticize it next time if you want to, but.
Absolutely, that'd be great. Thank you. So I think that then we'll probably wrap this up here. So I think the next things, we've got IETF 123 coming up in 2 weeks' time. It doesn't feel very long, and we're meeting on the Monday and the Tuesday. Is a 1 hour meeting on the Monday in session 2, I think, and a 2 hour meeting on the Tuesday in session 4. So that's quite late. Hopefully, we'll see a lot of you there. We will try and have, we'll cover some of the same discussion in those meetings, affecting in terms of what the proposal is going forward. We, Diego and I, will do a call for presentations, and we're happy for people to present. We want to make progress with the use cases and the terminology and the metrics. So we want to make progress with those, but at the same time, we also want to devote time, if we can, to sort of try and moving these issues forward as well. So we will try and, depending on what comes in terms of requests, we will try and dovetail those, but we may have like a dedicated 2 hour session. The second session will be something similar to what we've done today, where we try and go over some of these issues. We should try and summarize what's been said before for those meetings as well. So that might be something we try and do. After that, the proposal is that we will try and set up a regular cadence of informal interim meetings going forward, sort of design team feel like for this, where again the minute taking of things will be less strict, because I don't think we want to spend lots of time taking minutes, but we try and write conclusions. We will have issues open on GitHub as the plan, and allow people to add comments and things on there. And Jan, again, we'll be relying on Jan hopefully to try and edit the comments down and give us sort of concrete examples or concrete text that we can work towards getting consensus towards in terms of these models. And we'll have these different bits, put them together, and hopefully we can then get a sort of working point that we can all agree on as a way forward. Any last comments? I'd like to thank everyone who's
only
today.
For those of you planning to come to Madrid, don't believe that much on the rumors. Well, my experience in Madrid is that weather is going to be hot, but not that much. If you have been in places like Arizona or New York in summer, should be the same. Seriously, you never know, but that's basically don't be that much concerned about the temperatures. They are going to be high, but bearable for normal Westerners, and so we rely on air conditioning. We
Wait a second, that's the best accuracy you can give us? How about some Celsius?
Celsius, I think the forecast right now is that the top temperature we may get during that week is about 36. The central days of the central times of the day.
I'm not worried about the heat. I'm worried about the air conditioning. Can you tell us what the inside of the hotel is going to be?
I hope so, but don't expect a U.S. hotel in that sense. It's going to be a little bit warmer than the average U.S. hotel.
That'd be brilliant.
Do I want shorts or jeans?
I would say that shorts would be okay.
You mean
Okay,
in
that's
the meeting room or outside?
in the meeting room and outside. I mean, not on the street is up to you, but I mean inside the whole hotel will be more or less equally conditioned. That's
but
my experience.
would it be warm enough inside?
So shorts and a fur coat. Is that where the consensus is?
Exactly. That's the ideal combination. That's the IETF standard, isn't it?
Right, thanks, everyone.
Okay,
See you
take care.
Okay, guys.
See you soon. Bye.